Hi everybody, this is DK with Mr. V Amps, and this is a hopefully short video responding to some questions I got in regards to amplifier biasing and whether tubes can just be changed when needed, or if the amp needs to take a visit to a shop, or at least go under the meter if you know what you're doing. So this is the second filming. The first filming got way too rambly, and that's one of my problems. Sometimes it's easier to understand a concept than it is to actually teach it. So I appreciate everybody for tuning in and trying to bear with me. As we have talked about tubes a little bit before, a few of the concepts that we've discussed ad nauseum is when we put a voltage, a positive voltage, in this case of 410 volts, on the anode or plate of the tube, mass amounts of current will want to flow from ground, from the cathode to the anode, or from the cathode to the plate, depending on who you're talking to. They mean the same thing. If there is too much current flowing through the tube, it gets hot, it red plates, and it fails. On all of our tubes we have an element in here called the control grid, and it's one grid away from the cathode, and this grid can be used to turn the tube on or off like an electrical valve. Okay. There's essentially two methods that we can use to control the amount of current allowed to flow through this tube at idle. The first method would be to apply a negative voltage to the control grid, essentially turning it off. If this was a water valve with no negative voltage applied to the control grid, this would be the out-of-control fire hose, flinging the firefighter everywhere until somebody gets hurt. But by applying a negative voltage to this control grid, we essentially turn it off to a manageable trickle, if you will. And the audio signal can be used to turn it on a bit more or off a bit more to achieve amplification. Alright, so the first thing we are going to look at would be what we would consider a fixed bias with a negative voltage applied to the control grid. This amplifier schematic is a Fender Princeton Reverb. This is B1270 Silverface. Doesn't really matter. Most of these Princeton Reverbs with their 6v6s were a fixed bias. What we have here, we have 410 volts on the anodes or plates of the 6v6s, and we have the cathodes put directly to ground. It is also possible in some amplifiers where you will see an insignificant resistor size, like 1 ohm or 2 ohm, which really is barely any resistance from cathode to ground through 1 or 2 ohms. This is just used as kind of a measurement point because it makes it easy to determine how much current is flowing through a tube. That does not affect these tubes from burning themselves up. What does prevent these tubes from burning themselves up is this negative 34 volts that is applied through the 220K resistors to the control grids. It turns the tubes off about halfway. That is supplied through the tremolo circuit. Oh goodness, why does that have to be here? But the tremolo circuit, when it is operating, it actually will increase this voltage and then return it back to its 34 value rhythmically. If you were to increase this value from, say, 34 to 50, you would turn the tubes off more, thus decreasing your volume and shutting the tubes off. hey, that's how some tremolos work. So we're going to just ignore that. We have 34 volts that is supplied via a winding on the transformer. Got a resistor, one diode with the positive that way, meaning that the voltage is negative. It's always going to want to run toward the positive. We have a 50 microfarad capacitor and a 27K resistor, and these together should give us negative 34 volts. There is no way in this circuit from default to adjust that negative 34 volts. So Fender was assuming, and for the most part they were okay to do so, with this value of negative 34, any pair of 6v6s that falls within the normal manufacturer recommended specifications, you know, if your tubes aren't complete and total rubbish, you can plug and play them and you'll be okay, provided that they draw equal current, which is why we recommend you purchase your tubes in matched pairs. Pairs of tubes that are not matched can hum. That's usually your sign that one tube's got a problem. So if your bias is fixed and set, as long as it is fixed and set to a good value, you should be able to change your tubes when you need to without having to send the amp to a tech. But if your tubes seem to have failed prematurely, it could be that that bias is not the correct value because a component has gone out of tolerance. So it never hurts to ask your tech to check it. Or you can ask me to check it too. I'm here. Okay, this next schematic is the Weber 6A14. It is an extremely similar amp. I mean extremely similar. And you saw us build this amplifier. It's the seafoam green one, and we built this a month ago. This amplifier has the same 6v6s, and the cathodes are tied to ground. In my case, I put a 1 ohm resistor on each one so I could easily measure the current going through them, but again, it's an insignificant resistor. We do have the applied negative voltage, but there is a pot for adjustment. Instead of negative 27, the value that was used by Fender, we have a 22K resistor here and a 50K pot that will allow us to raise or lower the idle bias voltage. So we can actually reduce. We can take that negative 34 and maybe take it to negative 30 or negative 25 or whatever the tubes will allow. You can turn these tubes up a little bit hotter and get that hot tube tone that some people really like. A lot of bigger amps will have this bias pot on them also, and particularly amps with 4 to 6 tubes almost always have 4 to 6 power tubes will have a bias adjustment pot. It is fairly important to have the bias checked when you change these power tubes, because odds are this bias was set specifically for these tubes that are in there now and not just to sort of a generic catch-all value. The third method, which has become probably the most common I have seen in modern production amps, is what we call the cathode bias method. And this is a completely different method. Prior, in earlier versions, if you saw on the first two, they just had taken the cathodes and put them to ground. So they had an infinite supply of energy that would want to go up to the plates or anodes. And the tube could run wild if you didn't apply a negative voltage to the control grid. But in this case, there is no negative voltage applied to the control grid. Instead, on the cathodes, they have placed a significant resistor. In this case, 130 ohms, and this says 5 watt on the schematic. That's wrong. Should be about a 10 watt, just for safety. 10 or 15 watt, actually. And by applying this resistor now, DC voltage that would normally go flying through this tube now has to fight this resistance, thus lowering the amount of current allowed to flow through the tube. So again, by default the tube would just want to run wild, so we put resistance here to slow it down. We're turning the water pressure down at the source rather than turning it off at the valve. Okay? Almost all amplifiers that are cathode bypassed will also have what we would call a bypass capacitor. And if we know anything about capacitors, they pass audio signals, or AC signals, way better than DC, which they don't pass hardly at all. A proper working capacitor will pass no DC. So when this tube is asking for as much power as it can muster in audio, which will be AC variance, it will pass right through the capacitor. The audio signal demands will easily be fed via this capacitor, while the regulation of the idle current is handled via this resistor. This schematic is for our Smoke and Joe 2 that we built, our red amp that we built back in December. This is a cathode biased amp, and on an amplifier that is cathode biased, you should be able to change the tubes at will without having to rebias the amp, as long as the tubes meet the general manufacturer specifications. It is possible in certain amplifiers, such as a Vox AC30, you can look that up on our channel earlier. We had a Vox AC30 that was absolutely burning its tubes up. You would put brand new tubes in it, it was going crazy. The plate voltage applied on that amplifier was really out of spec, for it was too high. And the 50 ohm resistor that they had chosen for those 4 tubes was insignificant, and those tubes were running beyond their recommended plate dissipation. They would red plate, burn up, and fail. So we had to increase this resistor value to shut that down. So if your amplifier has, if you got it, let's say you got it new, and you got many hours of enjoyable service from it before your power tubes failed or wore out or sounded pukey, changing your power tubes and enjoying your amplifier again is very plausible scenario. However, if you just changed your tubes a month ago and your amp ate another set of tubes, then it would be time to have a technician take a look. If this resistor value is not high enough, your tubes may be getting too much current, causing them to overheat and burn, or if this bypass capacitor is leaking, it is essentially creating a short, allowing these tubes to flow too much current, and that can cause bad things to happen too. So the simple recap: if you don't know what your amp is, look for a schematic of it, or ask the manufacturer the question. Sometimes they won't give you a schematic, but they'll at least tell you. I had some amplifiers from the early 2000s from Epiphone, and before I knew much of anything about amps, that long ago, I asked, and they were kind enough to tell me this is the, like, we'll just go with the Valve Senior or the Blues Custom. I said, my Blues Custom. I said, if I'd like to change the tubes, they said this amplifier is cathode bypassed. They said if you're using quality tubes, they're essentially plug and go. Thanks, guys. So feel free to email your manufacturer to ask, or look up a schematic. If your amplifier is cathode biased, or the bias is fixed, like it is in that Fender Princeton, should be able to change your tubes and go and play. But if your amplifier is an adjustable bias, like my 6A14, or like a lot of the higher powered amps that maybe had 4 power tubes, or even like that crazy Ampeg with 6 power tubes, those are almost always adjustable bias, and it's generally a good idea to rebias them or to have the bias checked. On an amplifier such as this, that negative 34 volts is well in the safe zone, and it generally does not optimize the tone of the amplifier. So by taking that same general amp schematic and converting it to an adjustable bias, it allows you to kind of idealize the bias to get the most sound out of those tubes. But if I'm going to go change my 6V6s in my Monarch amp, I am going to need to check that bias again, because if my new tubes draw more current naturally than my tubes that I took out of there, I'm going to burn up my new tubes very quickly. Okay, hope that cleared up a few things. Thanks for watching. Y'all have a great day.